Hi everyone, I am Shaktir, Assistant Professor, Department of Civil Engineering, Hindustan College of Engineering and Technology, Coimbatore. And today we are going to see about the factors affecting the durability of a concrete. What is the durability of the concrete? A durable concrete is the one that performs satisfactorily under the expected exposure conditions for the specified life of the structure. The various factors that has been affecting the durability of the concrete includes the cement content, aggregate quality, water quality, concrete compaction, curing period, permeability, moisture, temperature, abrasion, carbonation, wetting and drying cycles, freezing and thawing, alkali aggregate reaction, sulfate attack, and organic acids. The detailed explanation of the above content as a first one, cement content. The quantity of the cement used in the concrete mix will also be a factor that has been affecting the durability of the concrete. The cement content used is lower than the required, then the water cement ratio becomes reduced and the workability also gets reduced. Adding more water to the mix results in the formation of the capillary voids, which will make the concrete as a permeable material. And in an excess cement content has been used, the problems like drying shrinkage, alkali silica reaction may occur, and which finally affects the durability of the concrete. Next one, it is the aggregate quality. And the use of the good quality of the aggregates in a concrete mix will surely increase the durability of the hardened concrete. And the shape of the aggregate particles should be smooth and round. Flaky and elongate aggregates affects the workability of the fresh concrete. For a better bond developments between the ingredients, rough texture angular aggregates are recommended, but they require more cement content. And the aggregate should be well graded to achieve the dense concrete mix, and the aggregate should be tested for its moisture content before using, and excess moisture in aggregate may lead to the highly workable mix. Next one is of a water quality. The quality of water used in the concrete mixing also affects the durability of the concrete. In general, potable water has been recommended for making the concrete. The pH of the water shall be in the range of 6 to 8, and the water should be clean and free from oils, acids, alkalis, salt, sugar, and organic materials. And the presence of these impurities will lead to the corrosion of steel or a deterioration of the concrete by a different chemical reactions. While placing the concrete, it is important to compact the placed concrete without the segregation. Improperly compacted concrete contains a number of air voids in it, which reduces the concrete strength and also the durability. Next one, it will be of a curing period. The proper curing in the initial stages of the concrete hardening results in the good durability of a concrete, and the improper curing it leads to the formation of the cracks due to the plastic shrinkage, drying shrinkage, and thermal effects, etc., and thereby reducing the durability. Next one, permeability. The concrete durability gets affected when there is a chance of penetratability of a water into it. Permeability of water into the concrete expands its volume and lead to the formation of the cracks, and finally disintegration of the concrete occurs. Generally, the concrete contains a small gel pores and the capillary cavities. However, gel pores do not allow the penetration of the water through them, and since there are the very small size, and but the capillary cavities in the concrete are responsible for the permeability, which are formed due to the high water cement ratio. And to prevent the permeability, lowest possible water cement ratio must be recommended, and the use of pozzolanic materials also helps to reduce the permeability by filling the capillary cavities. Moisture that has been present in the atmosphere will also affect the durability of the concrete structures, and the efflorescence in a concrete occurs due to the moisture, which will convert the salt into the soluble solutions, and which it evaporates the salts become crystallized on the concrete surface, and this will definitely damages the concrete structure and durability will be reduced. Next one, the temperature effects. The concrete is a heterogeneous material. When fresh concrete is subjected to a high temperature, rate of hydration gets affected and the strength and the durability becomes reduced. The concrete ingredients having a different thermal coefficient. So at a higher temperatures, spalling and detritation of the concrete happens. And since here we have been told that the concrete is a heterogeneous material, which indicates that it includes the various materials. But after the hardening, we can call the concrete as a homogeneous material. It is the basic assumptions during the design of reinforced concrete structures. Next one, abrasion. Detritation of the concrete also occurs due to the severe abrasion. When the concrete is subjected to a rapidly moving water, steel tires, floating ice, and the continuously wearing of the surface occurs and durability gets affected. Higher the compressive strength and higher will be the abrasion resistance. Next one, it is a carbonation. When the moist concrete is exposed to the atmosphere, the carbon dioxide present in the atmosphere reacts with the concrete and it reduces the pH of the concrete. When pH of the concrete reaches below 10, the reinforcement present in the concrete started corroding, and the corrosion of the reinforcement causes cracks in a concrete and the detritation takes place. Next one, it is a wetting and a drying cycles. When the concrete has been exposed to an alternate wetting and the drying conditions, such as tidal waves from the sea, etc., the secondary stresses are developed in a concrete. Due to these stresses, the cracks will form and the reinforcement has been exposed to the atmosphere. When the chloride or sulfates from the seawater meets the reinforcement, corrosion occurs and durability of the concrete has been reduced. And the use of low permeability concrete, proper cover for the reinforcement can prevent this type of the problems. Next one, it is the freezing and thawing cycles of the concrete. When fully saturated concrete has been exposed to the repeated cycles of the freezing and thawing, and it is detrited by the action of the freezing and softening of a water in it. It causes cracking on a concrete surface in the form of a maps, which is called as a map cracking and affects the durability of the concrete. The coarse aggregate present in the concrete gets also affected by the freeze and thaw cycles. Spalling of the concrete may occur. In this case, the durability of the concrete can be achieved by adding air entraining admixtures to the mix and also reduce the maximum size of the coarse aggregate. Next one, it is of the alkali aggregate reaction. Alkali aggregate reaction or alkali silica reactions takes place between the alkali content of the cement and the silica content of the aggregate. Is also a major factor that has been affecting the durability of a concrete. Due to this reaction, the concrete expansion occurs, finally lead to the severe cracking and the concrete gets detrited. And the use of the cement with less alkali content, that is non-reactive aggregates, pozzolanic materials like fly ash or a slag cement, and the lithium based admixtures in a concrete will help to overcome this problem. Next one, it is of a sulfate attacks in a concrete. When the concrete structures are attacked by the sulfate like a sodium sulfate, magnesium sulfate, etc., concrete disintegration gets happen. And the reaction is due to the chemical reaction between the hydrated cement products and the sulfated solutions. Sulfate attack generally happens when water used for the concrete mix contains a high sulfate content due to the unwashed aggregates. When the soil around the concrete structure contains the sulfate in it, and this can be prevented by using the sulfate resisting cement, by adding the slag cement, by decreasing the permeability, and etc. Next one, it is of an organic acid. When the concrete surface is subjected to an organic acids like an acetic acid, lactic acid, butyric acid, etc., the concrete durability gets affected severely. Formic acid on the concrete surface can lead to the corrosion of a concrete, and these are the various factors that gets affecting the concrete's durability, that is the lifespan of the concrete. I hope you understand this video. Thank you.